Pluto forces them to ascend and descend as its orbit crosses the path of another planet at the far reaches of our local planetary system. Pluto, the perplexing little planet, is generating a lot of excitement in the field of space science. Recent developments suggest that Pluto could potentially collide with Neptune, causing unease among astronomers and space enthusiasts. Well-known figures like Neil deGrasse Tyson and Michio Kaku have raised alarms about the possible consequences of this potential encounter. But how did Pluto end up on a collision course with its neighboring planet? Furthermore, what could this cosmic clash imply for life on Earth? Join us as we explore how Pluto's orbit is intersecting with Neptune and why this anomaly is leaving scientists concerned. Once considered a clear planet, Pluto underwent a reclassification and is now referred to as a dwarf planet due to its atypical orbit. Despite this demotion, Pluto continues to captivate and intrigue the astronomical community. Recently, concerns have been raised by esteemed scientists such as Neil deGrasse Tyson and Michio Kaku regarding Pluto's path, which may bring it into closer proximity with Neptune. This alignment suggests a series of potential interactions between these two majestic celestial bodies, with significant implications for Earth. Pluto's orbit around the Sun is unique, setting it apart within our solar system. Its orbit is notably elongated, crossing great distances as it travels. Since its discovery in 1930, Pluto has yet to complete a full revolution around the Sun, which adds to its mystique. Unlike the more circular orbits of the major planets, Pluto's orbit is unusually stretched, making it a distinctive feature in our solar neighborhood. The tilt of Pluto's orbit is another fascinating aspect, deviating 17 degrees from the ecliptic plane, giving it a sharper angle than the orbits of other planets. This combination of its inclination and elongated orbit adds layers of complexity to Pluto's movement around the Sun. One particularly intriguing characteristic is its periodic interaction with Neptune's orbit. For around 20 years in each cycle, Pluto's orbit takes it closer to the Sun than Neptune's, defying expectations given the separate locations of these two planets. Notably, Pluto's orbit is not circular but oval-shaped, leading to significant fluctuations in its distance from the Sun. At its closest approach, Pluto reaches about 30 astronomical units, AU, from the Sun, while at its farthest point, it stretches out to over 49 Australian dollars, nearly double the distance of Neptune from the Sun. Furthermore, Pluto's orbit is tilted at a critical angle relative to the major planets, contributing to the intricacy of its path and interactions with other celestial bodies, particularly Neptune. When Pluto and Neptune do meet in their orbits, their gravitational forces alter their trajectories over time. This complicated relationship highlights the interconnectedness of celestial bodies, with each object exerting gravitational influence over the others, shaping their orbits. In recent years, advancements in observational technology have enabled astronomers to track Pluto's path with remarkable precision, offering deeper insights into its orbit and potential impact on the stability of the outer solar system. While a direct collision between Pluto and Neptune remains unlikely, the possibility cannot be completely ruled out, prompting increased interest and scrutiny from the astronomical community. Despite its small size and distant location, Pluto continues to command attention. So, why hasn't a collision occurred between Pluto and Neptune? The answer lies in the gravitational interactions between planets. As soon as astronomers began studying Pluto's orbit, they were baffled by its strange behavior. Unlike most planets, which maintain a consistent plane as they orbit the Sun, the ecliptic plane, Pluto's path deviates sharply, creating an additional layer of mystery. The real puzzle arose when scientists realized that Pluto's orbit intersects with Neptune's path. Yet, despite this unusual overlap, Pluto's orbit remains stable, which speaks to the complex mechanics of space. Understanding how celestial bodies like Pluto, Neptune, and the Sun interact gravitationally is a significant challenge for astronomers. Predicting the movement of these bodies is akin to determining where they will be based on their starting positions and the forces they exert on one another. For Pluto, the interaction between its orbit, Neptune's orbit, and the Sun's gravitational pull creates a delicate and coordinated system that allows Pluto's path to remain predictable. Terms such as precession, libration, and the VSOP, variations séculaires de orbits planétaires, explain why Pluto's orbit may seem irregular but remains predictable over time. When Pluto crosses Neptune's path, it is still about 90 degrees away, preventing a direct collision. The phenomenon of libration ensures that Pluto remains safely out of Neptune's path, even when it approaches. The chance of orbital chaos highlights how sensitive a celestial body's orbit is to its starting conditions. Even small changes in a planet's position or velocity can lead to major shifts in its path over time. Using complex computational simulations, astronomers can model Pluto's movement in space, observing how slight adjustments in variables can dramatically alter its orbit. In the late 20th century, these simulations revealed that Pluto's orbit, while seemingly stable, can be subject to chaotic fluctuations. Even minor differences in Pluto's initial position or speed can lead to significant changes over long periods. Nevertheless, Pluto's orbit has remained largely stable over billions of years, suggesting that despite its apparent turbulence, its movement follows a discernible pattern. However, predicting the behavior of planets with such eccentric orbits is a difficult task. These systems are so unpredictable that long-term forecasting becomes a challenge. Simulations are useful in estimating possible outcomes, but they also demonstrate the inherent unpredictability of these celestial movements. Gaining a better understanding of Pluto's orbit is essential, especially when considering whether a collision with Neptune could happen in the future. This knowledge helps us understand how our solar system functions and reminds us that even seemingly unstable orbits can be stabilized by gravity and the broader dynamics of space. Exploring space uncovers many surprises, and Pluto's orbit serves as a prime example of such oddities. Unlike the orbits of other planets, Pluto's path around the Sun is more oval-shaped, meaning it is not a perfect circle. At times, Pluto even ventures closer to the Sun than Neptune does. While the chance of Pluto and Neptune colliding remains low, it is essential to recognize the forces at play. Gravitational pull acts like an invisible force, keeping the planets in their orbits. So, although Pluto and Neptune might appear to be on a collision course, their paths are meticulously shaped by gravity. Studying Pluto's orbit provides valuable insights into the delicate balance of forces that govern space. What might initially seem chaotic is often the result of a finely tuned system of gravitational interactions. Ongoing research and observation are crucial for expanding our knowledge of space, particularly in relation to our solar system.